right, 6th graders, we're on 7.2 multiplying fractions. We're on page 348 in your book, so take a look with me on page 348. There's a lot of models in here, and we'll talk about that in a second. I think sometimes the models are confusing, so when it asks you to use a model, you don't have to. You can do the math if you would like. Factor are, and this is clear back, factors are numbers. Well, let me write it. 3 times 5 is 15. 3 and 5 are factors. Okay, so factors are numbers that go evenly into another number. Okay, common factors are factors that numbers share. They have the same. For example, 6 and 4. The common factor for 6 and 4 is 2. 2 can go into 6 and 2 can go into 4. Simplest form means that you should reduce or convert, and let me show you the difference between the two. Reduce would be something like this, 6/8. You reduce by dividing by 2 on this one, and it would be 3/4. Convert means you need to change an improper fraction to a mixed number, 1 1/3. So those are ways of putting numbers in simplest form. So example 1, using a model to multiply fractions, and we'll look at the model, but you don't have to do them. They do get a little bit confusing. The table at the right shows the fractions of sporting goods stores' total sales in 4 categories. John, a salesperson at the store, made 2/3 of the push scooter sales. What fraction of the total sales is this? John's sales are 2/3 of 1/5 of the total. To find part of a part, you multiply two fractions. So he sold 2/3 of the 1/5 sales of push scooters. So 2/3 times 1/5 is the problem that we're doing here. And if I can find my thing here, 2/3 times 1/5. Okay, so to show you a picture of this, it says draw a 3x5 rectangle to model thirds and fifths. So you have the bottom of the fractions. So when you do that, you have 15 squares inside here. Check out these squares. And I'm not going to make you guys draw the pictures. I just want to show one to you to help you understand. There's 15 squares in here. Okay? It says here, shade 1/5 of the rectangle. Well, 1/5 of the rectangle would be, there's 1, 2, 3, 4, 5 there, so we shade 1/5 of it. So there's 1/5 of the rectangle. Now select 2/3 of the rectangle. Now 2/3 would be going this way. There's 1/3 and 2/3. Where they overlap, where both shadings occur, is our answer. So 2/15 would be the answer. So a little confusing with the models, but I will show you where that comes from and how it's done. If you just look at this fraction, this is how easy. Remember how hard fractions were when you were adding and subtracting them? The rules for fractions is as long as they are fractions, 2/3 and 1/5. If it was a whole number, you'd have to make it a fraction. If it was a mixed number, you would have to make it a fraction. But as long as they are fractions, it's just simply numerator times numerator, denominator times denominator. So check this out. You just take 2 times 1 is 2, 3 times 5 is 15. And we showed it with the model up here, but you don't have to do this every time. You just follow the rule. Top times top, bottom times bottom, or technically numerator times numerator, denominator times denominator. I'm not going to make you draw a model on these. Let's just multiply them. Okay, so here we go. 1 times 1 is 1. 2 times 5 is 10. 1/10. Top times top. 2 times 2 is 4. 3 times 5 is 15. Done. 3 times 5 on the top, 4 times 7 on the bottom, 15 28ths, and of course you look to see if you can reduce, and none of those reduce, so we're done. Finished. Okay, so here is our rule. Multiplying fractions. So the product of fractions, it's the product of the numerators over the product of the denominators. And that's where I was telling you it is numerator times numerator over denominator times denominator. And that's another way to write that. So number-wise, 3/4 times 5/8 is just 15 over 32. You just multiply straight across. Notice you don't have to get common denominators. You just plain multiply. A over B times C over D would be AC over BD. Done. Okay, so write the key concept box down. You need to be doing that. Pause this, get it all written down, and then when you're done, we'll move to the next example. So example number 2, multiplying two fractions is just top times top, bottom times bottom, and that would be 10, and that would be 15. Now on this one, you'll notice that we can reduce, because 5 can go into 10 and 15. So 5 goes into 10 twice, 5 goes into 15 3 times. So the answer to example 2 would be 2/3. Okay. So example number 3 says evaluate the expression 1/3 times n when n equals 2/7. So what we're doing is we're just substituting, and they kind of left some stuff out here. They're just substituting in for n the 2/7. So we got to put a times there, because when there's nothing between a number, even though it's a fraction, it's still a number and a letter, it means to multiply. So we'll put the dot, and we're missing a line right there. So it's just top times top. 2 times 1 is 2. 3 times 7 is 21. So the answer is 2/21. So we substituted, and then our answer is 2 over 21. Okay, so top times top, 1, bottom times bottom, 1/18. 3 times 1 is 3, 7 times 4 is 28. We still look to see if we can reduce, and we can't. We're done. This one we substitute in 3/4 times 3/5, 9/20. And then we're done. Substitute again, 2/3 times 4/9, 8/27. Is the product in example 2 less than both fractions? Why or why not? So example number 2, 2/3, 2/5 is one of them. 2/5 and 5/3. They want to know, is the answer, which is 2/3, less than both fractions? Well, this is 1 and 2/3, so it's definitely less than that one. Is it less than 2/5? Is 2/3 less than 2/5? Common denominators, that'd be 6, that would be 10. No, one of them is and one of them's not. One of them is and one of them is not. It's less than 5/3, but not greater than 2/5. All right, example number 4. Now, there's another little trick in multiplying. It's called simplifying before multiplying. You'll notice we've been multiplying, and then we look at the fraction and decide whether or not it can reduce. Well, especially when the numbers get a little bit bigger, we can basically reduce them before we multiply. So let's look at those. Kyle successfully completed 8 out of 15 passes during one football season. Kyle's friend Lou had a completion rate that was 1/4 of Kyle's rate. What fraction of passes did Lou complete then? So Kyle was 8 out of 15, and Lou was 1/4 of that. Of means to multiply. So in this case, what we would normally do is just take 8 times 1 and get 8 on the top, 15 times 4 and get 60 on the bottom, and then you'll notice you still have to reduce that. But another thing you can do is called cross-canceling. Cross-canceling is the simplifying before we multiply, and you can only cancel in an X like this or straight up and down. You can't cancel straight across from each other. So I always look across, look at the 4 and the 8, and this is where the common factors come in. And you think, is there something that can go into 4 and into 8? And there is. 4 can. So I have to be very verbal on this. I say 4 goes into 4 once, 4 goes into 8 2 times. Notice we canceled it down before we multiply. Now we look across 15 and 1. The only thing that can go into it is 1, so it won't change it. 1 and 2, so we're done. That would be 2/15. And let's go ahead and reduce this. What can go into 8 and into 60? Well, we know 2 can, so that'd be 4/30. And look, 2 can go in again, which would be 2/15. So this is intended to save you steps so you don't have to deal with these bigger numbers. Let's see how they did it. So they're showing you they're dividing out the number 2. I don't know what this one is. 2/15. Oh, that's the same one. Okay, so multiplying 3 fractions. If we're going to multiply 3 fractions, we can just multiply. You can take top times top times top. You can just multiply straight across the top here and straight across the bottom, but you'll notice those numbers will get kind of big. So what you can do is look across from each other, like look at the 2 and the 4. They're diagonal from each other, and is there a common factor? Is there a number that can go into both of them? 2 goes into 2 once, 2 goes into 4 twice. 3 and 6 are across from each other. So we can factor out a 3. 3 goes into 3 once, 3 goes into 6 twice. So you're looking, it gets a little messy. The only thing that's left on the top are 1, so it's just 1 times 1 times 1. The bottom, 2 times 2 is 4, times 5 is 20. 1/20th. So you can, remember, you can only cancel diagonally or straight up and down. You can't cancel straight across. And I don't know if they're doing the same thing that I'm doing. They just put them all together. And we got the same answer. So let's look to see if we can cancel anything first. 3 and 9 have a common factor of 3. So, and I always say them out loud, 3 goes into 3 once, 3 goes into 9 3 times. So we look at the 5 and the 8, nothing can cancel there. 1 times 5 is 5, 8 times 3 is 24. Done. Okay? 5/24. Here we cancel, look at across 5 and 15, 5 goes into 5 once, 5 goes into 15 3 times. 8 and 16, 8 can go into both of those. 8 goes into 8 once, 8 goes into 16 2 times. So that would be 1/6. You don't have to do it if you want to multiply 8 times 5 and get 40, and if you want to multiply 16 times 15 and get whatever that big number is, you go for it, but you'll still have to reduce in the end, and you'll still end up with this answer. And this makes it a little bit easier for you. We'll look across. 3 and 6 are diagonal. 3 goes into 3 once, 3 goes into 6 2 times. That's going to be 1 on the top and 20th again. 1/20th. This one, now look, the 7s, there's a fraction in between, but they're still diagonal. So 7 goes into 7 once, 7 goes into 7 once. 5 goes into 5 once, 5 goes into 10 2 times. 3 goes into 3 once, 3 goes into 9 3 times. Now it can get messy, but look at how small I got my numbers. 1/6, 1/6. And you have to write the original problem in order to do that. Look at the rule for multiplying fractions. Use variables to write the rule for multiplying the fractions. A, B, C, D, and EF. So we're taking A over B times C over D times E over F. That would be A times C times E on the top, B times D times F on the bottom. There it is. Okay, so try the cross canceling. If you're not sure how to do it, please ask or watch the video again at the canceling. Always look to cancel. It's easier to cancel before you multiply. So give it a shot and we'll see you next time.